Welcome to the session on probability, mutually exclusive and independent events. The objectives for this session are to understand mutually exclusive and independent events and determine whether two events are independent. So let's define mutually exclusive events. When events have no outcomes in common, they are referred to as mutually exclusive. And we also have that the probability of A or B occurring is probability of A plus probability of B. For mutually exclusive events, the closed curves in their Venn diagram do not overlap and will look something like the sketch you can see on your screen now. So we have the sample space S, we have the event A in one circle, and we have the event B in another circle, and there's no common area between the two. Let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. We're going to look at part A first. Let A and B be mutually exclusive events, and probability of A equals 0.3 and probability of B equals 0.1. Find probability of A or B. Let's solve this. For mutually exclusive events, probability of A or B equals probability of A plus probability of B, which equals 0.3 plus 0.1, which is of course 0.4. And now for example 1b. Find the probability of B but not A. Let's solve this. For mutually exclusive events, we have that probability of B but not A is equal to the probability of B. And this is of course equal to 0.1. And now for part C. Find the probability of neither A nor B. Let's solve this. For mutually exclusive events, probability of neither A nor B is 1 minus probability of A or B, which is 1 minus 0.4. And of course the 0.4 came from part C, which is equal to 0.6. We're now going to take a look at independent events. When one event has no effect on another, the events are independent. In other words, if A and B are independent, then the probability of A happening is the same regardless of whether B happens or not. The multiplication rule can be used to determine if events are independent. So probability of A and B equals probability of A times probability of B if A and B are independent. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So in this scenario, we have that A and B are independent events, and probability of A equals 2/5 and probability of B equals 1/9. We are required to find the probability of A and B. For independent events, as we mentioned, probability of A and B equals probability of A times probability of B, which is equal to 2/5 for probability of A times 1/9 for probability of B. which equals 2 out of 45. And now for example 3. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 3a first. The Venn diagram shows information about 3 A-levels taken by students in a form group. Find the probability that a student chosen at random is taking both maths and physics. So let's solve this. Now the probability that the student is taking maths and physics is 4, which is in the region of maths and physics together, as shown in the Venn diagram, divided by 25, which is the total number of students altogether. And all these numbers in the Venn diagram have now been highlighted in red. And now for part B. Determine whether taking maths and English literature are statistically independent. So let's solve this. Now the probability that a student is taking maths and English is 1, as highlighted in the diagram, divided by 25. And let's check now if the formula also holds. So the probability of maths times the probability of English should equal the probability that the student is taking maths and English. So the probability of maths is 9 out of 25, and the probability of English is 4 out of 25. So we multiply the two by one another, and that gives us 36 out of 625. Are these two equal? No. Since the two are not equal, the events are not independent. This brings us to the end of this session. If you have understood its contents, you should be able to understand mutually exclusive and independent events and determine whether two events are independent. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.